Wow, that's only like, oh no, just kidding. I thought it was only a 3-second delay, but no, it's more like 10. Oh, gosh, almost died. Okay, 6-2. Matrix multiplication, inverses, and determinants.
Those are certainly words.
They are certainly words. Okay, when you are multiplying matrices, now we reviewed in Unit 0 long time ago how to add matrices. It's real simple. They have to match, be the same size. You add all the components together. When you multiply it by a scalar, you just multiply everything. That's easy money. We've been knowing about that. If you don't remember how to do that, go back in your notes to Unit 0 and you'll figure it out, or look it up on Google. I don't care. Okay? But for multiplying a matrix, if we're multiplying matrix A times matrix B, in order to do that, why do they write? Okay, we're not doing that. This one is an M times N. We'll call this one a P by Q. Why not? So it's going to be like a 2 by 3 or a 6 by 8 or 4 by 7 or 1 by 2, whatever. You right? You follow me? Yes? Okay. So in order to multiply matrices, these inside numbers, these ones here, so the N and the Q in this example, they, the P is what I meant to say. So the inside numbers, they have to match. Okay? And the outside numbers will be the size of the result. Okay. So, for example, if we multiplied a 2 by 3 times a 3 by 8, we could do that in that direction. And the result would be a 2 by 8 matrix. But if we took these same two matrices and we tried to multiply them this direction, so an 8 by 3 times a 2 by 3, we could not in fact multiply those together. They would have no result.
Wait, so now we have multiplication that can't be done either way?
That's true. We do, in fact, have multiplication that can't necessarily be done either way. That is, in fact, true. Okay. Now, let's talk about how to multiply matrices by doing an example or two. Example. A is this matrix. 3, 1, 5, negative 2, 0, 4. And B would be negative 6, 1, 7, 4, negative 5, 3. And we want to find A times B.
When you're saying it like a 2 by 3, it's row by column.
What?
So these are going to be 2 by 3s because it's row by column, right?
Yes.
Okay. Always row by column.
A times B, A times B, and B times A. if possible. So A is a 2 by 3 matrix. B is a 2 by 3 matrix. That's true. Not possible either way. Not. Great. That was easy. Let's do the same sort of example. If we're real lucky, these will be multiplicable. A is a negative 2, 0, 3, 5, negative 7, 1. And B is a 2, 0, negative 1, 0, 9, 3. So A is a 2 by 3 matrix, and B is a 3 by 2 matrix. So it looks to me like they're multipliable, multiplicational in both directions.
Top one is on the bottom one on the right.
This is a 0, and that's a 0, and so is that. Okay. So let's do A times B. So to multiply matrices, we do row times column. Okay. So we would start by doing this row times this column. So we would go 2 times 2 plus 0 times negative 1. I won't always write down all these little intermediate bits. Plus,
The A was negative 2. You didn't put it in the second one, but you put it in the original.
plus 3 times 9. What is our answer going to be? How big is our answer going to be is what I'm trying to say, I guess.
2 by 2.
This is going to be a 2 by 2 matrix. So that, all of this is the first element in this matrix. Then we would continue on this row until we've gotten through all the columns. So we would hit the next row, or the next column. So this row times this column. So negative 2 times 0 plus 0 times 0 plus 3 times 3. So now we've done that first row, and we've done it times all the columns. So then we go to the next row. Do this one times this one. So 5 times 2 plus negative 7 times negative 1 plus 1 times 9. And then we do the last one.
So annoying to do every time, isn't it?
This row times this column. Well, after this first one, we won't write down all these. We'll just write down negative 4. Right? That'll at least save us some time and trouble. So 5 times 0 plus negative 7 times 0 plus 1 times 3. Okay, so then we've got to clean it up. -4 plus 0 plus 27 is 23. 0 plus 0 plus 9 is 9. 10 plus 7 plus 9 is 26. And 0 plus 0 plus 3 is just 3. All right, let's find B times A. What size matrix are we expecting out of that?
3 by 3.
A 3 by 3. Okay. So, first row times first column. 2 times -2 is -2. -2. -4, how about? Plus 0 is just going to be -4, right? Easy money. So then we move on to the next one. I do highly recommend using multiple colors because it's going to keep your life a lot more in line, but you do not have to do that. 2 times 0 is 0, plus 0 times -7 is still 0. These colors are very similar, but it'll be fine. 2 times 3 is 6. Plus 0 is 6. -1 times 0. No, -1 times -2 is 2. Plus 0 is 2. -1 times 0 is 0, and 0 plus another 0 is still 0, right? And then the last one in that row would be -1 times 3, which is -3 plus 0 is still -3. And then we grab the next thing. I don't have enough colors. Nine times -2 is -18 plus 15 is -3. Nine times 0 is 0. Plus -21 is -21. Nine times 3 is 27, plus 3 times 1 is 30. You can write down as many intermediate steps as make you get the right answer in the end. Okay, that's multiply matrices. Cobwebs dusted off, new skill learned. Okay, great. So we need a definition, identity matrix. An identity matrix is a n by n matrix with ones in the diagonal and zeros everywhere else.
So reduced row echelon?
Kind of. So, yeah, like reduced row echelon form, except it's a square matrix and it only has those things. There's nothing else going on. So the 3 by 3 identity matrix would look like that. 2 by 2 would look like that. 4 by 4 would be the same thing but expanded. 100 by 100 would keep on going, right? That's what we mean when we say the identity matrix. Great. So, didn't we oh, no, we didn't. Yeah, but we are going to skip that. Okay, great. Because that's a waste of time. Everybody, and just for like, in case there's something on the homework that vocabulary-wise throws you off, everybody flip it over to 378 and look at example 3. Okay, so the only reason that I want you to look at example 3 is vocabulary. That first matrix looking thing there is the matrix equation of that system. And then the augmented matrix would be that one where it's got the dotted line, right? And then they used Gauss-Jordan elimination and they solved it using that method. So that's the only thing we really care about from that thing is vocabulary. Great. So let's figure out, we need another tool. We've figured out what the identity is we need another tool. We need to know how to find the inverse of a matrix. And before we learn how to find the inverse of a matrix, let me explain why we need to find the inverse of a matrix so we can put it all in its proper place. So, how do I solve this?
Subtract the 5.
Okay, so I subtract the 5. Why do I subtract the 5?
Is it off the x?
Because that's the inverse of adding that. So in order to get rid of something in an equation, we have to do the inverse to get rid of it. Multiply by its inverse or the additive inverse in this case, right? So in order to get rid of a matrix in a matrix equation, we have to multiply by its inverse. So we have to figure out how to find the inverse. Making sense?
Yeah.
Okay, good. So that's why we are doing what we're doing. So here's how to find the matrix. How to find the matrix. Well, you take the correct pill. Is it the red pill or the blue pill? I don't know why I never can remember which one's which.
Blue pill.
The blue pill takes you out of the matrix. The red pill lets you stay in the matrix and unaware. Do what? Well, it's, I would argue, fairly overrated these days.
Oh, for sure it's overrated.
But it's a good movie, but it also has a lot of profanity and a fair amount of violence.
I watched Breakfast Club. What was it called?
It has more profanity than The Breakfast Club.
Seriously? That thing I felt embarrassed watching with my parents.
Well, The Breakfast Club has themes in it that would probably be a little bit embarrassing to watch with your parents.
It was a profanity, not even themes.
Well, there you go. Well, there you go. I say that. I don't know. It's been a while since I've watched The Breakfast Club. I don't remember it having a ton of profanity, but it probably did because I watched it as an adult. Okay, so first we want to know whether we can find whether two matrices are inverses. Okay, so we're going to determine whether. Yes. A equals -4, 3, 3, -2, and B equals 1, -2, 2, -3. No, wait. I started copying a different problem. That's gonna not give us the result we wanted. Timeout. How about 2, 3, 3, 4? Our inverses. So you actually already know how to do that. So let's see if we can puzzle what it would mean if they were inverses. So let me illustrate with another example. If I have 4x equals, I don't care, 24. How do I solve that?
Divide by 4.
Divide by 4. So when I divide by 4, or in this case, I'm going to write it different just because it's going to make my point even better. If I multiply times 1/4, what is now in front of the x? A 1, which is in fact the multiplicative identity. Because if I multiply 1 times x, it's still x. Right? So that's what the identity means. The identity matrix is something that you can multiply times something and it stays the same. Right? So if these are inverses, then when I multiply them, what am I going to get?
1.
I'm going to get what is 1 as a matrix?
Oh,
The identity.
the 1.
So if I multiply this a times b and b times a, and both times I get the identity matrix, they're inverses. So let us multiply these.
Are we allowed to use calculation for this?
It depends on what you mean. So your calculator will do that for you. No, you're not allowed to do that. Okay. But you're allowed to do -4 times 2. So, -4 times 2,
-8.
-8, plus 9 is 1. Looking good so far. -4 times 3 is -12, plus 3 times 4 is 12. It's 12. It's 0. Looking great so far. 3 times 2 is 6, plus -2 times 3 is 0. Still working. 3 times 3 is 9, plus -8 is 1. It works that way. Great. Let's try it the other way.
And it has, like, they both have to, so if something doesn't
Right.
come out, then you can just, like, YOLO and don't have to finish it.
Correct. Unless you made a mistake. So 2 times -4 is -8, plus 9 is 1. 2 times 3 is 6, plus -6 is 0. So that's what I was doing, yeah? Yeah,
Remember,
good.
it just stopped for a second.
I know. We had to jump start it. 3 times -4 is -12, plus +12 is 0. 3 times 3 is 9, plus -8
I'm gonna assume it's
is 1. They are inverses. That's great. So that's how to tell if two matrices are inverses. So this is the work that you would show if you were determining whether they are inverses. So what about if I have a matrix and I need to find do I want to teach you that method? Yeah, I do because of 3 by 3 matrices. In fact, that's what I'm going to give you the example. There's an easier way to do this. What I'm about to teach you. There's an easier way to do this if it's a 2 by 2 matrix. You just have to memorize a little formula and do the determinant, and Bob's your uncle, great. But you can't do that with a bigger matrix. So I'm going to do this as an example with a 3 by 3 matrix. So we're going to find the inverse of A, which this is the same as like sine, cosine, tangent. This is not a to the negative 1. This is, well, it kind of is both. But this is the inverse of A, if it exists. Because not every matrix has an inverse. A is -1, -2, -2, 379, 147. Okay. So, to find the inverse using this method, we write a doubly augmented matrix. So we're going to write this matrix. And then this matrix. Oh yeah, there's also an easier way to do it with 3 by, I forgot we're going to do that in this lesson too. I thought that was coming up later. Oh yeah. So should I just skip this method? No. Yes. No. Let me look at the homework and make the decision based on that. Yeah, I think we're going to skip this method. Because we're going to do this, we're going to do the 2 easier methods, and we're not going to do a matrix that's any bigger than this. So what we would do, I'll explain to you how to do this, because you actually could do this now, but we're not going to do it. What you would need to do right now, what did we write? We wrote the 3 by 3 with the identity, right? So what do you think you're going to do? Make a guess.
Figure out what will give us the number that we want on the right.
Yeah, kind of. So basically what you do is you use row operations, so like lesson 1, to turn this side into the identity and this side into whatever it turns into. And if it turns into something, yeah.
Wait, if it turns into what?
If it turns into something, then it has an inverse.
Turns into something.
Like if it doesn't, like there are some matrices that don't have an inverse, but
So that side turns into like.
Anything at all?
you don't have to work, no. If it comes out as numbers, you're great.
It comes out as numbers.
Yeah, you're great. We don't care. We're not going to do it that way.
I don't stress about it.
Okay, so let's do determinant of inverse and determinant, because we're going to relearn that at the same time, of a 2 by 2 matrix. Okay. So if A is this matrix, A, B, C, D, then the inverse of A is, I'm going to write it this way. I'm going to write it this shorthand version and then a longhand so we can remember a thing all at once. It is 1 over the determinant of A times this matrix. Okay, so let's take this two puzzle pieces at a time. Okay, so first puzzle piece, what is this?
The
So you take this downward diagonal and you flip them, and the upward diagonal, you just change the signs, right? Right? So how do we find the determinant of a 2 by 2 matrix? Does anyone remember? I know you don't even know, but do you guys remember?
No.
There's some equation, but I don't remember. I can't remember what it is.
You just multiply this minus these multiplied. So the determinant of A in this, and I'll write this out in a long version, would be 1 over A times D minus C times B. And then we're still multiplying times that other thing. Okay? Let's do an example. Let's find the inverse let's do 2 examples of a 2 by 2. We'll do one of a 3 by 3. 2, negative 3, negative 2, negative 2. We'll start with that one. Times it. Yeah, because I'm right-handed. Okay, so the determinant would be negative 2 times negative 2, which is negative 4, minus negative 2 times negative 3, which is positive 6. So the determinant would be negative 10, right? That is the determinant of these.
And the determinant is what?
Is a single number representing the whole matrix. That's about as complicated of a definition as I care to give at the moment. But it's where you do this. So this negative 2 times negative 2 times negative 2, and then minus the up diagonal. Negative 2 times negative 3, which is positive 6. So it's negative 10. So we're going to multiply to find the inverse. We're going to multiply 1 over negative 10 times 2 negative, no, stop, slow down, go back. We flip these around, so negative 2 here and positive 2 here. And we flip the signs on these. So positive 3 and positive 2, right? So when we're multiplying by a scalar, what do? Yeah, it's kind of distribute. You just multiply all the things. So this would equal positive 1/5, negative 3/10, negative 1/5, negative 1/5.
So is that the inverse?
That is the inverse. And you could prove it by multiplying them together and getting the identity. Let's do one more 2 by 2. Do what? You're going to end up with a lot of ugly fractions because you're doing 1 over something times that. That's going to be very common in this particular chunk of your life. Okay, so let's also find the inverse of negative 4, 6, 8, negative 12. So we should start out by finding the determinant. So negative 4 times negative 12 is positive 48. Minus 8 times 6 is
Can't do that.
48. 48 minus 48 is 0, so we would have to be multiplying times 1 over 0. Therefore, it does not exist. Yay.
What was the 3 dots for?
That means therefore.
Therefore.
You can't do a 0 with a line through for undefined.
Isn't that like null set?
So it is null set, and that would technically be wrong in this particular problem. Technically, ever so technically.
Why?
Because null set is a set with nothing in it. This doesn't exist. I know. Weird theoretical math crap. It would depend on how grumpy I was that day. So, you know, probably not, but we are in pre-cal, so you never know what might happen.
No.
I did. That was actually a super helpful thing. I don't even remember where that was. Let me see if I can find it and I'll show it to you. Maybe this will clear it up.
Like, I understand it as a concept, but just it makes me sad.
Well, neighbor.
I like my little shorthand does not exist.
I just put D-N-E.
Yeah, there you go. Look at that. That's like such a good explanation, even though it's like super silly and dumb. It's like a perfect explanation. Okay. Let's do a 3 by 3. Times it. Yeah, sure, we can make it happen. Why not? We're brave adventurers. It's a 3 by 3.
I don't know, for both like the English class, they have a reason.
Oh, yeah.
How's Frankenstein? Y'all enjoying it? It's great.
Oh, you read the first 4 chapters, which is literally just the letters from the dude to his sister.
He's on a boat.
He's on a boat. You get to see the monster yet, except on the ice being silly.
Being silly.
I like the word
Running
silly.
away. We've met that guy, right?
Yes, that's the dude that.
Oh, we're not going to find the inverse. Oh, yeah, we are. Oh, this example is not actually doing what I thought I was going to do, but that's fine. Because the first bit is something I didn't teach you last year. So because you do need to know how to find the determinant of a 3 by 3 matrix. This is a different method.
And the determinant is the
So, no, the determinant is a single number. You have to have the determinant to find the inverse.
Oh. Okay.
Of a 3 by 3. So last year in Algebra 2, I taught you how to do this using the deal where you have your matrix and then you rewrite the first 2 columns and then you do all that stuff. Y'all remember what I'm talking about? Where you multiply, and you're adding and then you subtract. Y'all remember this? Yes? So that's how we learned how to do it last year, which is still my favorite method. So if you want to dig up how to do it that way and use that method, you can, but I'm going to teach you a different method today. Bless you. The determinant of A, which is, as I've reminded you and shown you, is we use that notation. Instead of square brackets, we just use like absolute value looking things. I know, confusion. Context matters. Is A times the determinant of this 2 by 2 matrix. I'm going to write this one and then I'm going to ask you some words so that you can do it and memorize it without like going crazy. So where did that little matrix come from? Yeah, so this one times the 2 by 2 matrix that if we deleted out those things. Minus B times this matrix where does that come from?
Bottom 2 rows, we get rid of the middle.
Yeah, chopped out the middle. Plus, we chopped out where B is, and then determinant of those. What do you think the last one's going to be?
CDCF.
C times this determinant.
Or ADCF. No, just kidding.
Well, the C would be the outside one, and then we chop that off, and it's the one that's left. Okay. So a bunch of tiny little determinants times some scalars.
That one was what? Sorry.
What?
The C was what?
Well, it's the same. So to get the first one, we pick A, and then we chop off this, and you got this left. B, and then we pick B, and it's minus on that one. And we chop off that and this, and we have what's left. And then to get the C one, we have C, and then we chop that row and column off, and it's what's left.
Get rid of the column of the number you're
Column
multiplying
and
by,
row.
and then just do everything else in the bottom rows.
Mm-hmm. Yes. Okay, so let's do one example if we have time. Yeah, we do. Easy money. We got this. If I can find my book. So, we're going to find the determinant of this matrix. 1, -2, 1, 4, 0, 3, -3, 1, -2. So, it'd be -1 times the determinant of the matrix 0, 3, 1, -2, right? And then minus -2. I'm going to write that all the way out just for clarity. If you want to do the minus -2 and write +2, that's fine. And then we would have the determinant of this little matrix plus 1 times the determinant of this little matrix. Good. So 0 times -2 is 0, minus 3.
Huh?
0 times -2?
To find the determinant, we just did this on this last one. You multiply here and subtract minus the multiply here, yeah.
Yep.
So 0 minus 3 is -3. Plus 2 times 4 times -2 is -8, minus,
Wait, go back. How did we get that -1?
I just drag it from here to there, and it came from here.
Okay, and then you'll do the.
Yes.
Why is the 3 negative?
Because it would be 0 minus 1 times 3.
So -8 minus.
-9, so plus 9, so +1. Four times 1 is 4, minus 0 is still 4. So, look at us. We're going to even end a titch early. If you had a problem like like this problem, and this is, I'll write your homework after I give this diatribe, and then I'll let you see if you can find it on your calculator with your last couple of minutes. So, the instructions to this problem say find the determinant of each matrix, then find its inverse if it exists. So, the determinant is not 0, which means it has an inverse. So now we would need to find the inverse of this matrix. And the way you're going to find the inverse of a 3 by 3 matrix is you're going to put it in the calculator and you're going to find the inverse thing and push enter. So figure it out while I write your homework on the board.
Great.
And we're just doing like the matrix.
What?
You're plugging in the stuff that's the 3 by 3?
Yeah, you'd put this matrix, in there, and then there will be a button that's like inverse of the thing.
Okay, I did something wrong, but I don't know what.
Okay? What?
I got 1 out of my old.
Does this line look the same?
Well, you did the math like in your head, and I was trying to write it all out.
Well, let's write it in. So this would be 0 times -2 is 0, minus 3. This one would be 4 times -2 is -8, minus -9. And this would be 4 times 1 is 4, minus -3 times 0 is 0.
And then you brought the -2.
-2 is +2.
Why did I get a different answer than when I left it as a negative? Like minus -2.
Minus -2? Look,
Times the bit. You have to multiply it by the bit first, don't you?
so that would have been, this has got to be +1, right? And then, so -2 times 1 is -2, and -2 is still +2. Did you multiply it times the -8 first for some reason?
I
Or?
found out what I did wrong.
Where's the math button?
It's a big button that says math.
No, I still have it wrong.
I don't see the button that says math.
I'm the determining button.
Oh, no, I found the math button.
So you on numbers like 12 through 18, you are welcome to do Gauss-Jordan elimination like on your calculator. You don't have to. If you want to do it by hand, you're welcome to do it by hand, but you're welcome to do those by using Gauss-Jordan elimination on your calculator if you wish.
So would you just like plug it in? And or would you?
You would
If I'm
do the
determining
augmented matrix stuff.
the determinant of,
Yeah, but you need to find inverse because determinants you got to do by hand.
okay, so I found the button that says the determinant, you know.
You don't want the determinant button. You want the inverse.
Oh, well, inverse is there too.
Yeah.
I just don't know how to put it into matrix form.
Well, you gotta go to your matrix mode. You gotta be in the whatever thing it is.
The video started off in the main menu.
Just in home.
Yeah.
Well, you can maybe figure out how to do that. Probably this, but then you got to figure out how to do all those other you can do that pretty much. But your brackets are right there. But
I genuinely do not know what I did wrong.
Transpose.
We used to take it and move it to a
-1 times -3 is not -4. That's what you did.
So when I go to data and data/matrix editor,
that still